Hello, welcome to my tutorial in mathematics class for grade 10. Learning objectives. Number 1, apply factoring polynomials in solving word problems. And number 2, analyze and solve word problems involving polynomials. Our main lesson for today is the application of polynomials or problem solving involving polynomials. Let's have problem number 1. The volume of an aquarium is 120 centimeters cubed. If its width is 1 more than its length and its height is 1 less than its length, then what are its dimensions? Again, the width is 1 more than its length and its height is 1 less than its length again. So take note that length is the point of comparison or the only one being compared, and it's stated here twice. Therefore, our basis is length, so our x represents the length. So let me write here, let x be the length of the volume. What else? The width is 1 more than the length. If the length is x and the width is 1 more than the length, so therefore the width is represented by x plus 1. So this is our width. And the height is 1 less than. This time it's less than. So x minus 1 is our height. Now, how do we come up with our equation or with the polynomial? So take note, the volume. The volume of an aquarium is 120 centimeters cubed. We have to recall the previous lesson about volume, particularly the formula. So V, volume is equal to, can you recall the formula for volume? Yes, it's length times width times height, or simply length to width height, even without the multiplication sign. Now, let us replace each letter by the values here. So, x is for the length, so we replace L with x. X plus 1 is for the width. Let us replace width here with x plus 1. And finally, the height is x minus 1. X minus 1 is equal to, it's not 0 here because volume is given, which is 120 centimeters cubed. So let us write 120. So this is our equation. And out of this, we can come up with the polynomial by multiplying x, x plus 1, and x minus 1. This time is the other way around. We came up with the factors first. So take note, these are the factors, x, x plus 1, and x minus 1. And the roots here are 0 for x from x, and then negative 1 from here, and positive 1. Our problem now is not looking for the roots, but simply looking for the value of x for us to determine the dimensions. So when we say dimensions, these are the parts of the aquarium, which are length, width, and height. Now, if you are asked to find the polynomial, we have to multiply this part, then equate everything to 0. So let's do that. 120 is equal to, let me multiply first x plus 1 here and x minus 1 before I multiply to x. But it's up to you. You can also multiply first x by x plus 1 and then multiply the result by x minus 1. But I like it first to multiply these two because it's easier. So x plus 1 times x minus 1 is x squared minus 1. And times x outside. So this will be x cubed minus x. So x times x squared is x cubed. and x minus times negative 1 is negative x. And then equal to 120. So this is our polynomial. And if you want to equate it to 0, simply transpose 120 to the other side. So this will be 0 is equal to x cubed minus x minus 120. So this is the polynomial. Now, this is not yet the final answer to the problem because the main problem is we have to look for the dimensions. There are two ways to solve this. One is by looking at the polynomial and apply the theorems that we've learned before, looking for the roots. Looking for the roots, for the other roots, or simply look at the given here, the given factors, and do trial and error. What will replace x that when we multiply all this, we'll get 120. And I think that's easier. So looking at 120 and 1 here, the possible roots are 1, 2, 5, what else? 4, 10, 20, and so on. But take note, this is 120. So let us limit ourselves to 1 to 6 only for the value of x. So let's do trial and error. But before that, let me erase this part. So let me erase this part and look for the possibility of the values of x. So we are looking for the values of x. Let me erase this part. Anyway, you know already that this is our polynomial. And now we're solving for the value of x so that we will know the dimensions of the aquarium. So let's do trial and error using 5 first. If x here is 5 and 5, all x should be 5. So meaning to say, this will be 5 times 5 plus 1 is 6 times 5 minus 1 is 4. Multiplying this should give us 120. And if it's correct, then these are the dimensions. 5 times 6, 30 times 4 is exactly 120. So we got it. Why 5? Why 5? It just came from the factors of 120. Because we know that 5 is a factor of 120. So it just came out that we got it right away. So replace x with 5, replace x here with 5 then, and 5 here, and multiply the result. The answer is really 120. So therefore, the value of x is 5. Now, going back here, x is equal to 5, and x plus 1 is 6, and then x minus 1 is 4. So therefore, the length is 5, the width is 6, and the height is 4. So these three are the dimensions of the aquarium. So I hope it's clear. It's only by finding the factors, and it came out that 5 is really correct. We got it right away. So we're done with this problem. The dimensions are length is equal to 5 cm, width is equal to 6 cm, and the height is equal to 4 cm. So that's all about this problem. Let's have example number 2. If 3 consecutive integers has a product of 120, what are the integers? Consecutive integers, you learned this before, that if you will represent this, it will be look like this. X is the first integer, followed by x plus 1, second integer, and x plus 2, third integer. And it says here the product is 120. Simply multiply all this. X times x plus 1 times x plus 2 is equal to 120. Then from here, we can come up with our polynomial. So this is x times x, x squared, x times 2, that's 2x. 1 times x is x, and 1 times 2 is 2, equals 120. And then distribute x times x squared is x cubed, plus x times 2x is 2x squared. And finally, not yet final, x times x is x squared again, and x times 2 is 2x, equals 120. So x cubed plus 2x squared plus x squared here is 3x squared, and plus 2x, then transpose 120 minus 120 equals 0. So this is our polynomial if you will be asked to find the polynomial. Now, let's have the question, what are the integers? Going back to the given here, to the factors, we can estimate again, or we can do trial and error again to look for the value of x. Or if you want to try this also, this will help us to look for the possible factors. And again, the possible factors of negative 120 are negative 1, positive 1, but this time we take only positive because we are talking of 3 consecutive integers. But integers can be negative also. Now, let's have 2, 3, 4, 5, 6. What else? And all the other factors of 120. So, let's do trial and error again. Let's try 3. If x here is 3, let me use another color. If x here is 3, then this will be 3 times 3x here, 3 plus 1, this will be 4. And this one, 3 plus 2 will be 5. Let's multiply this. 4 times 5 is 20 times 3, that's only 60. It cannot be 120. So therefore, x is not 3. Now let's have 4 or 5. Okay, let's have 5. If x here is 5, and x here is 5 plus 1, that's 6. And 5 plus 2, that will be 7. Will this give us 120? Let's see. 5 times 6 is 30 times 7. That's what? 30 times 7, that's 210. So it's higher than 120. Meaning to say we have to go lower than 5. And that's 4. So let's see if this is 4. If x is 4, then 4 times, this is 4 plus 1, 5, and 4 plus 2, 6. Then multiply this 3, 4 times 5 is 20, times 6 is 120. So we got it. Therefore, the value of x is 4. So x here is 4, which is the first integer. And then 4 plus 1 is 5. 4 plus 2 is 6. So the three integers are 4, 5, and 6. I hope the problem is clear and it's easy for you to understand. Problem number 3, find 4 consecutive even integers such that the product of the first, second, and fourth is 240. This time, it's consecutive even. A while ago in number 2, it's only consecutive. Consecutive integers and even number is not mentioned, or odd number. So this time, there is condition that the 4 consecutive integers should be even. And how do you represent even, consecutive even integers? It's like this. So x is the first, x plus 2, second integer, x plus 4, third, and x plus 6, fourth integer. Now, how do we come up with the equation? So it says here, the product of the first, second, and fourth is 120. So we have to multiply only the first, second, and fourth. So it should be x times x plus 2 times x plus 6 is equal to 240. Since we are not asked to give the polynomial, let's go straight to solving it using the shortcut method, and that is by trial and error, by replacing x with the possible value. Since this is 240, the possible values of x can be 2, 4, 5, 6, and all other numbers that can divide 240. So let's try 5. Let's try 5. Let me use another color. If x is 5, so this will be 5 times 5 plus 2 is 7. 5 plus 6 is 13. I'm sorry, 5 plus 6 is 11. Will this give us 240? Let's see. 5 times 7 is 35 times 11. I think it's not 240. So, what is 35 times 11? I think it's higher than 240. Let's lower than 5. So, let's make 5 4. So, let's say if x is 4 times 4 plus 2 is 6 times 4 plus 6 is 10. Then let's multiply this. 4 times 6 is 24. 24 times 10 is 240. So exactly this is what we are looking for. Therefore, the value of x is 4. Let us now replace the representation here. So x will be 4. And then 4 plus 2 is 6, followed by 4 plus 4 is 8, and finally 4 plus 6 is 10. The 4 consecutive even integers are 4, 6, 8, and 10. That's all about this problem, and I think it's easy for you to understand. Now let's have example number 4. Find 4 whole numbers such that the product of the first, second, and fourth is equal to 48. Also, second is thrice the first. The third is 2 more than thrice the first. And the fourth is twice the first. So the point of comparison here is the first number. So this is our clue that x is our first number. What about the second number? The second is thrice the first. So thrice the first, therefore it's 3x. 3x is the second number. What about the third number? The third is 2 more than thrice the first. So it should be 2 more than thrice the first. The first is x, so 3x, and plus 2. 2 more than thrice the first. This is the third number. And finally, the fourth number is, the fourth is twice the first. The fourth number is simply 2x because it's twice the first. Now, for us to come up with equation, it says here, the product of the first, second, and fourth is 48. Product of the first, second, and fourth is 48. So, x times 3x times the fourth one is 2x. The product is 48. So, it looks easier this time because all of these are monomials. We can see any plus or minus. So, x times... No need to do trial and error because we can get the value of x right away. So x times 3x, 3x squared times 2x will give us 6x cubed. Then copy equals 48. Divide both sides by 6. Cancel 6. X cubed is equal to 48 divided by 6 is 8. And then get the cube root. Get the cube root of 8. So x cubed or cube root of x will give us x. Cube root of 8 is 2. We take only the positive because it says here whole numbers, no negative. So the value of x therefore is 2. Now let's have all the 4 whole numbers. X is 2, so the first number is 2. Then 3 times 2 is 6, second number. Third number is 3 times 2, 6 plus 2, 8 is the third number. And finally, the fourth number is 2 times 2, 4. The 4 whole numbers are 2, 6, 8, and 4. And let's see if multiplying the first, second, and fourth will give us 48. So 2 times 6 is 12, times 4 is really 48. Therefore, 2, 6, 8, and 4 are the correct whole numbers. That's all about the application of polynomials. I hope you learned from my examples. Thank you for watching and listening. God bless and always study well.